very much noise. And propeller is the first propeller noise is the cavitation. Cavitation induced vibration and noise. To prevent mechanical noise, as you can see, we designed like that. This is the engines in the enclosed acoustic shielding and damping mounting, and we can use the common bed and elastic mount here and vibrating blocking and absorbing coating outside the submarines and inside the submarine the absorbing materials. And during the design to reduce the hydrodynamic noise, we can optimize the design and simulation, and especially the well-designed propeller reduce the cavitation noise. And another thing is the shock-proof underwater explosion. Underwater explosion is the two categories: near-field explosion and far-field explosion. Near-field explosion, when the warhead detonated at beneath our ship, first bubble expand and lift the hull to the you can carries upward. And when the bubble is collapsed, our ship is can break the ship, fall into the void. This near field explosion is normally come from the torpedo explosion and very near the mine explosion. This is also the affected to the hull strength and onboard equipment. But far-field explosion is this is our ship, and this some the enemy attack underwater explosion. For example, the mines or depth charges like that. The far-field explosion is our effect of the shock to the ship. Normally, the whole structure is safe, but the onboard equipment is very damaged. So for that we simulate, and after that we real ship explosion tested. This test is very expensive and dangerous. In these days, many countries simulate only, but up to now the simulation is not exact. So simple test method is developed. So next, trends are integrated mast. This is in the past many masts and the sensors and antennas like that, and very complicated decals, and they generate many radio reflection, so RGS is very high. This is the recent mast, integrated mast. Inside that, like this, all antennas and the sensors and communication equipment inside that. This material is the very high technology material, FSE, frequency selective surface material. The radio signal is the go through. but enclosed from the environmental cold weather and rainy. This is good. When this sensor is the blockage these areas, but like this all 360 all around the signature is no blockage. So minimize the RCS IR signature and maximize the combat performance. Combat systems optimal designed and no sensor blockage, very integrate different antennas, increase argo coverage, improve maintainability because we protected from the wind and salinity and the rain like that we protected and reduce shipbuilding time. That means it is her. This is the master. Master design and build in electric company. This whole design and constructed in shipyard. They have independently construct and after that plug in the hull. And so improve sensor durability because the all sensors are protected from the environmental condition and improve EMI problem. This many sensors are collected. They interface the electromagnetic interference, and in the integrated master there are many stacks and divided inter EMI problem flow. And save this area and the top heavy weight. Now the modular design for multi-mission, the easy upgrade. As you can hear and understand, technology has changed very quick, and battle environment is changed according to the worldwide situation and the technology development. So, but this warship, once constructed, we can use the about 30 years operation. During the 30 years, battlefield mission is changed and technology is changed. So we cannot make new ships according to technology change and the mission is changed. So idea is that so modular design, multi-mission to adopt change the mission and to adopt easy upgrade. This is the example of the frigate. This is trimarine frigate. There are many spacious areas for upgrade. For this is for the the launch and recovery systems for example the unmanned systems and the large flight deck. According to the operation kinds, they can select the helicopter type and the large mission bay and large hangars areas. Hangar means the helicopter house and the integrated ISRs and guns and the habitability areas. Habitability area also the adjustable to according to the crew number of crew and the operation men and mission bay left. Mission modular. This is the very convenient. So for modular design, the modular open architecture is very important. And the combat system. There are many combat systems trained and developed, but in these days the common trend is that augmented intelligence and integration AI into the bridges, naval ships. It allows officers watch for ship safety, outside operation, and tactical situation, and vital information. All they can the common use and the share the information. Open systems, open architecture technology will work in this similar ways. Because the open architecture system is that we can change on the repair and fix the many new systems and the interoperability. Artificial intelligence aids. This is very, very important in these days. Artificial intelligence is a combat system allowing their users to quickly process data and reach crucial decision faster, providing vital advantage in combat, and provide the crew with the most important information as well as the recommended courses of action. And they need to threat analysis, respond to threat in combat. As my opinion, in not so in not so near future, we depend on the more artificial intelligence aids. And
Professor, Professor,
yep.
I have a question.
Yep.
With artificial intelligence, do you think that in the nearby future we don't have to put people in the boats, like you just have boats running like drones, but with boats? I don't know if you understand. Like, do you think if in the near future we'll have ship without crew on it?
Oh, that the warship itself, no crew? You mean that?
Yeah. Do you think it's kind of weird, but do you think it's possible?
I think finally destination maybe, but I think my opinion is this is not near future, long future. I think because we carry out many missions in the warship for small unmanned systems, a very simple operation, but totally integrate and the convergence, the technology and the operations maybe not easy. Yeah. In the next page, we can see some things. So this time, maybe for the time being, many unmanned systems, unmanned surface vehicles, unmanned underwater vehicles, and underwater air vehicles all together on board and independently. All the cooperation is cooperation operation is carried out. This is the our country developed USD and UAV like that. UUV. This is very big unmanned AUV. UAV. This is United States. As I know that they finished the test. Very dangerous. Yeah, as you can see, this is the unmanned maritime system. This is the anti-submarine warfare ship. This is the only one mission for submarine warfare ship. This is the unmanned. This is the very large underwater vehicles. This UUV carry out their mission about nine days by the battery charging. And this is the very special and unique. The Russia's nuclear power, nuclear bomb, nuclear torpedoes, 100 knots and 1,000 depths they can operate, and the total the cruising mileage is 10,000 miles. And this is the Chinese AI unmanned submarine, but this is the real or not, I'm not sure. But someday, as you still mentioned, someday our final goal is the unmanned warships. But this is very, very dangerous. Without the man, unmanned warship operate and autonomous decision making is very, very dangerous. So, as I know, the all unmanned systems approved by the our headquarters before before attack. So I think the perfect unmanned ship warship is not easy, I think. Another automation and the reduced crew is very important. But, as I know, in the Navy, most expensive problem is come from the mankind cost. To reduce the mankind cost, reduce the crew. For that, we have to automated systems. So automate the machinery control systems, automate integrate the bridge systems and damage control systems, and integrate the condition assessment systems, total ship training systems. As a result, we can reduce the crew reduction. For example, DDG 1000. This is very, very 4 billion cost, very large ships, but only 150 crew is enough. Frame in French, 100, and LSC of 50. This is very, very good, very, very good designs. But in my country, still, crew is very many people, many crews are working. About 200 maybe in destroyer like that. 200 or the 150, 200 maybe. Oh, this is some example of the most advanced warship design trends. I'll try to explain. After that, we are try to see some videos. Before that, I tried it. This main trend is that tumble from air piercing. This very narrow ship with a great distance of the waterline and to reduce the RCS, because this very, very hard inclined to reduce the RCS. There's no flare. Normally ship there are many flares like that, but this is no flares. This very, very sharp the hull shape to this ship go through the waves. So wave piercing hulls. Introduce the power systems. this ship has the all fully electric power system, because the normal ships most of the energy used propulsion, but this ship needs a very high energy weapon needed, so power flexibility is needed. So to solve that, they adapted integrated power system and total ship computing environment. Single encrypted network, they all shipboard computing applications emerged, ranging from the RISE and machine control to its radar and weapon system. They are total ship computing environment. Electronic modular enclosures. They have each ship carries 16 EMS. Shipbuilding innovation packaging, 235 individual electronic cabinets, and easy install, easy maintenance, and Mark 57 vertical launch systems, advanced gun systems. Mark vertical launch systems, normally we plug in the many missiles, VLS like that, but this ship is the peripherally we inside that we deploy, install the missiles. But this problem is too expensive. They say the one ship, $4 billion. So as I know, they stopped the construct this kind of ship because too expensive. Oh, this is very, very interesting ship. I strongly recommend our students, you interested this the design trends. I think in the future, our students can find out your job, because actually this is not real ship. This is some concept ship. So maybe personally, I think that we can reach that not so maybe very near future we can reach that. For that we developed many difficult technology. We have to develop that. So I think that this kinds of technology, our student can interested, then you can get a job and all the research items. I think. As you see, this is very unique and very special control. The United Kingdom suggests this concept. Dreadnought, new dreadnought ships. Let me see that platform. Very stealthy flares. No flares. This is primarily the trimaran 1, 2, 3 trimaran hull form, and very low level, and no flare, and very hard inclination angles. So RCS reduction, shaping, no equipment outside. So all the equipment hide inside the structure. Very low hull, and semi-submersible. I'm not sure this is true or not, but I think it's possible. If the flooded more water in the ballast tank, we can the submersible maybe possible, I think. And wave piercing sea, as you know, about this large ship can cruising the 50 knots, because they go through the waves by the wave piercing hull ship. largest possible deck. This is deck for UAV and helicopters operation, and ultra strong acrylic hulls. All the hulls are graphene coated to reduce the friction drag, and the acrylic hull, they see through hulls, ultra stealthy. Extendable flight deck and hanger. With this hanger is extendable and the deck is extendable. And this is very, very interesting areas. Large flooded dock. If you open this gate 6 like that, there are very, very big dock here. 2 launch, recovery, USB, UUV, and Marine Corps vehicles. Under the dock, they have the boom pool to deliver the swimmers, vehicles, or UUV on the water. Propulsion system is the fusion reactor, very high efficient turbine, silent electrical driven water jet may be adapted, and the very, very, very high level automation. This is the platform kept the design trends. Let me see another combat system. Very interesting. You see the one is that this is the hovering tethered quadcopter. This line is the carbon nanotubes, transmit very high voltage electricity for use of the UAV and sensors. Normally, this the quadcopter like that, and in operation go to the higher level of the air. So this the tethered carbon nanotube is very high technology because very high energy laser weapon inside there. So higher the helicopters, the more long range and easy to engage the many close and long distance the missiles or the UAVs and things like that. Energy weapon, electromagnetic railguns inside that, just like our star, our films, the Star Wars, and defensive hypersonic missiles fuse inside the side like that. In the many holes, the defensive hypersonic missiles, Maha 5, high energy weapons, and very close in combat to stop small enemy craft. And super captain torpedoes at outriggers. This area only fire the torpedoes. 300 knots torpedo in the water, super capitating. So there are many core technology inside that. So they have if you're interested about that, you can have the opportunity to develop this new technology. 3D holographic command table, as you see that. Rotate and zoomed. Command examine the particular areas of the battle space, above water, underwater, in the air, or offshore, onshore. All the situation, the board is holographically displayed. And modular open architecture combat system. Using modular mission base, extensive use of the robotic systems, and operation, even the very complex situation, and the
Professor Na, we need to close this session. Oh,
Yep.
good time.
Last my slide. The United States Office of Naval Research, 5 major science and technologies like that. This category of the technology, United States Navy want to develop. So if you're interested in this technology, you can have a chance to join the developing technology, and by using that, you can using your worship, right? Okay. My lecture is finished. Worship design research will be good job for your future. I hope every student have a chance to work and develop new technology and for warships. Yes. Okay, any questions? Just before your students suggest fully unmanned autonomous warship you suggest, but I hope so. But for that, your student have to develop new technology, I think.
All right. Thank you
Yep.
very much. Sorry for the audio problem at the beginning, so we are delayed a little bit. Thank you for attending and your special lecture, and see you next time, student.
Thank you
Bye-bye.
for attending my lecture. Thank you. Bye.